Hey everyone, and welcome back. So today we are jumping into a huge topic in the cloud-native world. What on earth do you do with your data? Specifically, we're going to break down how you manage persistent storage for your stateful apps when you're running them on Amazon's Elastic Kubernetes service, EKS. All right, let's get right to the heart of it. This is the one question that I swear keeps every Kubernetes architect up at night. Picture this. You've got your app. It's running beautifully inside a pod. But here's the thing about pods. They're designed to be disposable. They can get terminated, rescheduled. They can just crash. So when that happens, what happens to all your precious data? Where does it go? And the default answer? Well, it's poof. It just vanishes. See, by its very design, a container's local file system is what we call ephemeral. It's temporary. So the second that pod disappears, all of its storage is just wiped clean. Now that's great for stateless apps, no problem there. But for anything that actually needs to, remember stuff, we're talking databases, user uploads, you name it, this is an absolute deal breaker. So how do we fix this, right? Well, this is where Kubernetes gets really clever. It has this fantastic concept called a persistent volume, or PV for short. Now think of a PV as a chunk of storage that just lives inside your cluster. It's totally separate from any single pod. It has its own life cycle, which means it hangs around even after the pod that was using it is long gone. Okay, but a pod can't just go and grab any PV at once. That would be chaos. Instead, it makes a request, and that request is called a persistent volume claim, or a PVC. I love this analogy. Think of it like a ticket for a coat check. Your application's PVC says, hey, I need 10 gigabytes of really fast storage, and then Kubernetes looks at that ticket and goes to find an available persistent volume that actually fits the bill. So the whole workflow is actually pretty simple, and honestly quite elegant. Here's how it works. First, an admin, or let's be real, usually an automated process, sets up a pool of available storage. Those are PVs. Then your app puts in its request with a PVC. And finally, Kubernetes plays matchmaker. It takes the claim, finds the right volume, and binds them together. And once they're bound, that's it. They're a dedicated pair. Now this all sounds great in the abstract world of Kubernetes, right? But a persistent volume isn't just magic. It has to be backed by real, actual storage somewhere. And since we're talking about EKS, that somewhere is, of course, AWS. So that leads to the big question. What are our choices? What does AWS offer us? And here they are, the big three. So you've got Amazon EBS, EFS, and S3. Let's break them down. Think of EBS as basically a high-performance hard drive that attaches to one thing at a time, perfect for a database. Then you have EFS, which is more like a shared network drive. Multiple apps, multiple pods, they can all read and write to it at the same time. And finally, there's S3. S3 is just this massive, scalable place to put, objects. It's for your backups, archives, all that good stuff. Now pay really close attention to that access scope row, because this is a huge deal. EBS is stuck in a single availability zone. EFS can stretch across multiple AZs, which is great for high availability. And S3, S3 is on a whole other level. It's regional or even global.
Okay, enough theory. Theory is one thing, but let's actually put this into practice. To really see how you choose between these, we're going to architect a super common example, a simple photo gallery microservice. So our little photo gallery here has three totally different storage needs. First up, we need a really fast, super reliable database for all the user info and photo metadata, who uploaded what and when. Second, we need a shared spot where all of our web server pods can access the actual photos to show them to users. And third, we need a cheap, cost-effective place to stick old photos that people don't look at very often.
All right, let's start with the database. This one's a no-brainer. It's got to be Amazon EBS. Any database, whether it's PostgreSQL or MySQL, it craves that super fast, low-latency block storage. And since it's only ever going to be accessed by one pod at a time and performance is absolutely key, EBS is the perfect fit. So we just create a PVC asking for that kind of storage, and bam, Kubernetes would hook our database pod up with a shiny new EBS volume. Okay, next up, the actual photo files. Now remember, for high availability, we're probably running multiple copies of our web server pod. And here's the kicker. They all need to read and write to the exact same folder of pictures. This is the textbook use case for a shared file system, which makes Amazon EFS the clear winner here. A single EFS volume can be mounted by tons of pods all at once. It's exactly what we need. And finally, what about those archives? Storing terabytes of old photos on super fast EBS or EFS would cost a fortune, right? So this is where Amazon S3 comes in to save the day. But here's what's really important to understand. We don't use the normal persistent volume system for this. Instead, our application code itself, using the AWS SDK, talks directly to S3. It's a totally different pattern because it's solving a totally different problem.
Okay, so our architecture is starting to look pretty solid. But a good architect doesn't just plan for everything to go right. A great architect plans for when things go wrong. So let's talk about failure and look at the risks that come with these storage choices.
Look, every single choice you make in tech has a trade-off. There's no free lunch. With EBS, the biggest risk, by far, is that it's tied to a single availability zone. So if that entire AZ has an outage, guess what? Your database is down too. That's why having a solid backup and recovery plan is absolutely non-negotiable. Now with EFS, the risk is a little different. It's about performance. If you get a sudden spike in traffic, you could hit your throughput limits, and that'll slow your whole app down. So you got to be monitoring it and be ready to scale up that throughput when you need to.
All right, let's boil this all down to the key takeaways, the stuff you really need to remember. Rule 1, use EBS for your single-pod, low-latency workhorses, like databases. Rule 2, use EFS anytime you need multiple pods to share the same files. It's all about that read-write many access. Rule 3, use S3 for pretty much everything else, your backups, your archives, your big data lakes. And maybe the most important rule of all, always design for failure. That means using EBS snapshots for backups and having a real tested plan for what to do if an entire availability zone goes down.
And that really brings us to the one question I want to leave you with. Because it's not enough to just get your app to store data. The real goal is making sure that data can survive, well, anything. So take a hard look at your own architecture right now and ask yourself this: is it really, truly built to survive a disaster? Thanks so much for tuning in.